So at this point, it's really looking like a bad PCM, doesn't it? So, channel 1 yellow traces our ASD and fuel pump control wire. You can hear the relays. They're being pulsed, and then our 8-volt feed is noisy, and it's around 6 volts. Now let's go back to our 5-volt reference here. You see, our 5-volt reference is just fine. Nice and, flat line, no problems. 8-volt reference, wonky. And there's no excessive current on there. I measured it with my amp clamp. Nothing's really pulling this 8-volt reference down. And you can see as it warms up, if something warms up inside this PCM, see how it's trying to pull the control side, trying to ground it, and the relays are clicking louder and louder. It's getting better and better. And I wonder if maybe heat this guy up and see if it gets better. That'll be pretty conclusive. But yeah, at this point, wow, it's getting real loud now. Crazy. So maybe I should just leave it on and let it, see if it comes back to life. And then, if the truck starts, then that'll be cool. We'll see what happens to our 8-volt reference too. Yep, maintenance required is flashing. We'll see if we get our communication back. You can see this thing, there's actually a date on here. 96. So this thing has been apparently updated at the dealer in November of 1996. See where this goes. So something crazy just happened. I unplugged the ignition module, our clicking stopped, our 8-volt ref is down to 3.6, and our control pin is at 12 volts. Now let me take the relays out. Okay, our control pin's down to 0. Oh, that's crazy. How would that even affect anything? See, they're not clicking. I'm going to plug this ignition module back in. Let's just set up right here. Plug it back in, and we're up to 6 volts again. Our relays are clicking like crazy. Wow. How is that tied into anything? And how would that raise our 8-volt reference from 3 to 6 volts? That's what I don't get. So maybe we should take a look at what wires go to this ignition module, see if there's anything going on there. Alright, here's where we're at. 8-volt reference, right? Turn the key on. It's cooled back down. There's no clicking or anything. Relays are back in. Our 8-volt reference is at 5.6 volts. It's cold outside. The Varus drained its battery, so we're going primitive here. Now, you know what? Wire right from the positive lights my test light, which is connected to battery ground. I'm going to get this 8-volt reference up. Now, this is 12 volts here. It's just an experiment, you know. Ideally it would be at 8, but I'm just gonna put it right on that wire. 12 volts straight into that 8-volt reference. Now, my suspicion is that 8-volt reference, it doesn't just feed, you know, the cam, crank, ignition module. It also feeds the internals in the PCM, like you know, the logic. So here's what we're going to do. Bypass positive 12 volts right into that regulator. See what happens. Here we go. Hear that? We're at 12.2 on that wire. I heard something. I think the fuel pump pried. For a check, engine is still off, so key off, key on. Check this out. Our bulb check now works. Let's see if it fires up. Woo! Nice. We got battery voltage in that comm wire. Let's see what happens when we take it off. Dies. 5.3 volts. Back on. That's crazy. Let's see if it'll just fire right up. Hell yeah. Maintenance required lights on. Don't really care. It works. That's pretty wild. So we still have to do a few checks here, but at this point, it looks like our 8-volt regulator inside the PCM is bad. Now the question is, should we put in a new PCM, or should we just run a, you know, an ignition on wire to that 8-volt reference and say screw it, it's good enough? I want to check the 5-volt. Lost the connection there. I also want to check this 5-volt reference, see where that's at. But that's pretty cool. I mean, we made the truck run. So yeah, we're still going after the PCM. I'm on the 5-volt reference wire. The key is off. We're still at 5 volts here. I unclipped my jumper wire, dropped to 0. Jumper wire's on, 5 volts. Beauty. Gotta check out the exhaust system on this thing. Straight flow, no nonsense, baby, yeah. Nice. So at this point, I mean, I guess we're basically done. It's a PCM issue. All we need is an 8-volt feed in that wire. We can make an external regulator, I guess. I mean, that's it. All we need is 8 volts. Let's get the Varus out, see if that charged up, and see if we can talk to this thing. So, obviously before condemning the PCM, we have to make sure that nothing on that 8-volt reference tree is pulling that voltage down. Now, that's a high impedance circuit, so even, you know, a partial short to ground will reduce that voltage. And you know, we were seeing, what was it, 5.5 volts, so it's not much lower than 8. And I was actually talking to Eric just now from South Main Auto Repair, and he said, based on experience, Chryslers with, you know, crank no start, no comm, first thing he checks is the crankshaft position sensor, since these things apparently are known to short out and pull that 8-volt reference down. So remember, the 4 things we have to check are on that tree. So let's see here. Zoom in a little bit. So there's 5 volts, there's 8 volts, 8-volt tree. Let's see what we have. Crankshaft position sensor feed, camshaft position sensor feed, vehicle speed sensor, and then finally go across here, up to our ignition control module. Now if you remember, when we unplugged this guy, the signal actually went from 5.5 down to like 3 volts. So, you know, you can, a couple possibilities there. If maybe this thing's actually helping to pull up that 8-volt reference, because it does have an ignition feed right here, 12 volts. So, you know, if that 8 volts isn't steady, then any module will kind of go crazy. So we already know where the connector is there. We can unplug that. We know where the connector for the camshaft position sensor is. We've already unplugged that and seen no change. Now the vehicle speed sensor and the crankshaft position sensor, that's what we're after. We have to unplug those and verify if our 8 volts comes back at the PCM, then we're going after the sensors. If it doesn't, we're going after the PCM. So let's take a look where this crankshaft position sensor is. It says it's mounted on the right side of the engine block behind the exhaust manifold. Okay, right there. Now maybe that's a clue, since, you know, the owner said he has to heat up, he puts his kerosene heater under the engine block, and maybe that changes the resistance of that crankshaft position sensor, and, you know, the 8-volt tree comes back to life or something. So that's a very real possibility. So we'll have to find that guy. Hopefully there's a little pigtail coming off. It's not too hard to get to. And then we also have to look for the vehicle speed sensor. See where that lives. I'm assuming it's on the back of the transmission. Yep, back of the transfer case. Vehicle distance sensor, interesting. So we can unplug that too. Alrighty, let's go back to the truck. Turn the key on, plug in our voltmeter, and monitor the 8-volt reference wire. Alright, everything's plugged in, key is on. We have our, it's almost 6 volts. Now maybe this you know, increases as the engine warms up or something, and we slowly get our PCM back online. So let's start unplugging things. First we'll do the easy stuff. Here's the cam sensor. Okay. We're up to 6.04. Unplug this ignition module thing. Okay. Now we're back down to 4.1. Alright. Let's get down here. It's nice working on lifted trucks, isn't it? So let's see, transfer case. There's our vehicle speed sensor right there. Let's unplug that guy. unplugged. Let's check our voltage. 4.65. Alright. Last but not least, we have to locate this crankshaft position sensor. It said right side of the engine block. Okay. Under the exhaust manifold. There's the exhaust manifold. There's the motor mount. Let's see. Get to it from up top. There's a wire. Well, I'm gonna look for it, and once I find it, I'll let you guys know. Alright, I finally found it. So we're still at 4.7. Coming down here. Alright. So the sensor itself lives right by the engine mount. So you can zoom you in on this guy right there. There's the wiring going to it. It comes over here, right by the oil filter. And there's a connector. This guy right here. So I'm going to focus you in on the voltmeter, unplug it, and you guys can tell me if that voltage goes back up to 8. Alright, so with all the sensors unplugged, the voltage stayed at 5 to 6 volts on the voltmeter. So none of our sensors are shorted out. Now for final confirmation, I'm doing an ohm check on the wire, okay? And we have our ICM unplugged, all our other sensors, the cam, crank, and vehicle speed sensor are unplugged. We have 2.6 kilo ohms. Now, if that tree is not connected to anything, we should be at, infinity. Now the only thing that's left connected is the PCM connector right there, okay? Now, I'm going to unbolt that, take it out, and we're going to watch the ohm reading here. And that should drop to infinity. And if it doesn't, then I don't know. Maybe we forgot to unplug something, but I'm going to take this out. You will keep watching the ohm meter. Alright, PCM is unplugged. Alright, fantastic. So we have no shorted sensors. And that tree, the wiring integrity is good. Again, we're back to the PCM. Our 8 volt feed, there's something wrong with that, and that obviously also controls the logic inside, for the communication. So at this point, we can try heating up the PCM, see if our 8 volt returns. We can do our little bypass test again, maybe with a 9 volt battery, see if our communication comes back. A couple of things we can do. We can unbolt the PCM, bring it outside the house, heat it up. So let me think of the next coolest test here, but at this point we're definitely after this PCM. Alright guys, here's the setup right now. Test light to battery positive to that 8 volt wire. We're at just about 8 volts and we have communication. This is our data stream. Alright. We can check our codes. Codes only. No codes present. Imagine that. Of course not. So that's the issue. The 8 volt feed is not functional in this PCM, and if we supply it with 8 or more volts, then hey, it runs, it communicates, everything works. So I think in this case we can we can put in a reman PCM. Maybe they're about $300, or let's see if we can actually I don't know, open this one up, see if we can find the 8-volt regulator, or just put an external one in. I'm pretty sure we can find one online, so let's see what we can do. Just for reference, when that wire, the jumper wire from battery positive to that 8-volt pin, we got 0.1, 0.2 amps going to that pin in the PCM. So, it doesn't draw a lot of current, but that 8-volt regulator apparently can't even put out a couple tenths of an amp to keep the system alive. So, with this setup, we're at 12.2 volts on the 8-volt control, and if the truck runs, then heck, we might just keep it like that. Let's see. A long crank time, I don't know, but so we got battery voltage on there. It instantly dies as soon as you take that jumper off. So if we can set up an 8-volt regulator, that would be ideal. We can even do a resistor bridge. Maybe that'll be interesting to set up in an 8-volt regulator here. Actually, that's not a bad idea. Let's see if we can make one.